Hi everyone, good evening. So this is the QR code of my compiler design textbook. This will be helpful for BTech, MTech and GATE. This will be helpful for BTech, MTech and GATE. You can buy it from PW store, that is the QR code. Okay. This is the QR code of my Telegram channel. Please join the Telegram channel and you answer the questions there. Okay. So we were discussing context-free grammars or context-free languages, right? Today also our topic is going to be context-free languages. Today also our topic is going to be context-free languages. Okay. So let us see what is a partial derivation. Let us see what is a partial derivation. Right. The name itself says that this is not full derivation. Right. The name itself says that this is not full derivation. Right. Root need not be s. Root need not be yes. The root need not be s. Every expansion must correspond. Every expansion must correspond to some production of G. Every expansion must correspond to some production of grammar G. To some production of grammar G. To some production of grammar G. Right? The yield the yield of the tree is a sentential form. Is a sentential form. Right? 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 For example, take this grammar. S derives AB, A derives AA or epsilon, B derives BB or epsilon. Right? Right? So, using this grammar, using this grammar, derive AAB, or let us say partial derivation. So, S derives AB, A derives AA, A derives AA, right? Now this is called partial derivation. Root need not be s, right? Root need not be s. S is deriving A, capital A, sentential form, right? So this is called partial derivation. This is called partial derivation. Okay. Now let us see ambiguous grammars. Ambiguity of grammars, right? Ambiguity ambiguity of grammars. Ambiguity of grammars, right? Rule number 1. So there is no algorithm to find out whether a grammar is ambiguous or not. Ambiguity problem is undecidable. Undecidable means there is no algorithm. Okay. So we can use some guidelines to guess that some of the grammars are ambiguous, right? But using these guidelines, you will not always be able to answer the question, but most of the cases you will be able to answer the question. Okay. Rule number 1 is, if there is a production, if there are productions, if there are productions, if there are productions like S derives S1, S2, if there are productions like S derives S1 or S2, then there are two paths. Then there are, if there are productions like S1 derives S1, S2, then there are two paths. S can derive S1 or S can derive S2, right? Then there are two paths. And if L of S1, language generated by S1, partial derivation, intersection language generated by S2, partial derivation, is not equal to 5. If they are generating some common strings, then it is ambiguous. Then it is ambiguous. Then the grammar is ambiguous. Then the grammar is ambiguous. Right? What does it mean? If you have two productions, S derives S1 or S2, then we have two paths, S derives S1, S derives S2. If S1 and S2, both of them derive a common string, then for that common string we have two parse trees. For that common string we have two parse trees, right? For that common string we have two parse trees. Hi Ayush Patel, good evening. Ayush, I am fine. Okay. Then there are two paths or two parse trees for the same one. Now answer this question. Is this grammar ambiguous? Okay. S derives S1 or S2. S1 derives AS1 or epsilon. S2 derives BS2 or epsilon. S1 derives AS1 or epsilon. S2 derives BS2 or epsilon. Right? Tell me for this grammar. Tell me for this grammar. Is it ambiguous? Is it ambiguous? Ayush, every day we have 1 hour lecture, and lectures will go on till 15th of December. Till 15th of December we have 1 hour, 1 hour classes. Okay. So S1 derives S1 or S2, S derives S1 or S2, S1 derives AS1 or epsilon, S2 derives AS2 or epsilon, right? Is this grammar ambiguous? Is this grammar ambiguous? Is this grammar ambiguous? Yeah, Anish. Prashant, try it once again. Getting 50 marks in GATE if you start now is easy. Okay, Ayush, thank you so much for your compliment. Is this grammar ambiguous? Try it. पेपर का लेवल इतना मुश्किल नहीं होता है, मतलब अगर आप अच्छे से प्रिपेयर करेंगे तो पेपर का लेवल इतना मुश्किल नहीं होगा। अगर आप अच्छे से प्रिपेयर करेंगे तो पेपर इतना मुश्किल नहीं लगेगा। और कंप्यूटर साइंस का पेपर बहुत ही इजी होगा कंपेयर टू अदर पेपर्स। Very good, Anish. Grammar is ambiguous, right? So this grammar is ambiguous, right? So tell me, what does S1 derive? What is S1 deriving? Tell me what is S1 deriving. Very good. Very good, Prashant. Both S1 and S1 to S2 have empty strings. S1 is deriving A star, right? Now what is S2 deriving? S2 is deriving B star, right? Now if you look at L of S1 intersection L of S2, it is A star intersection B star, which is equal to epsilon, which means you can generate epsilon in two ways, right? What are the two ways? S can generate S1 and S1 can generate epsilon, or S can generate S2 and S2 can generate epsilon. S2 can generate epsilon. Right? Answer this question. Is this grammar ambiguous? S derives AB or CD. S derives AB or CD. A derives AA or epsilon. B derives BBB or epsilon. C derives CC. This is capital C. This is capital C. Capital C. CC or epsilon. D derives DD or epsilon. Tell me whether this grammar is ambiguous. Tell me whether this grammar is ambiguous. Manoj Kumar sir, big fan. Very good, Manoj. Is this grammar ambiguous? Just see what AB is deriving, what CD is deriving, then you can answer this question, right? What AB is deriving, what CD is deriving. Just see what AB is deriving, what CD is deriving, right? Right. So you can see that A is deriving A star and B is deriving BB star and C is deriving C star and D is deriving DD star. Can you answer it now? Can you answer it now? Can you now answer it? Yeah, Manoj Kumar, how was the course? How was the course, Manoj Kumar? So now you tell me whether this grammar is ambiguous. So S is deriving AB or CD. And I have individually given you what A is deriving, B is deriving, C is deriving, D is deriving, right? You can combine all of them. You can combine all of them, right? Now what is AB deriving? AB is deriving A star followed by BB star. What is CD deriving? CD is deriving C star followed by CC star, DD star, right? Right? Now is there any intersection between these two? Now, is there any intersection between these two languages? So if you write AB intersection CD, L of AB intersection L of CD, that equal to A star BB star intersection C star DD star, right? Do you find any intersection? Do you find any intersection between these two? If I put 0 here, 0 here, 0 here, 0 here, I'm going to get epsilon, right? So epsilon is the intersection, which means by AB and by CD, epsilon can be generated. So you will get two parse trees for epsilon. So you will get two parse trees for epsilon, right? So it is going to be S derives AB, A derives epsilon, B derives epsilon. S derives CD, C derives epsilon, D derives epsilon. Therefore, the grammar is ambiguous. Therefore, the grammar is ambiguous, right? So how did I derive this? There are two paths. I'm just trying to find out what is the language generated by two paths, right? I have a question for you, bro. India has 80% Hindu pop people. Then why people use abusing words for mothers that should be scared? And I think I have not talked about women's safety, as you all know. Okay, so uh, I can't answer this question, but that is a nice question, Shivam. I can't answer that question. Okay, fine. So why people are using bad abusing words for mothers means it depends whether they are not educated. They might not be educated, right? Generally educated people don't use abusing words, right? Yeah. So this grammar is ambiguous. This grammar is ambiguous, right? Right? Now answer this question. S derives AB or CD. A derives AA or epsilon. B derives BBB or epsilon. Capital C, this is capital C. Capital C derives C, small c, capital C or small c. Capital D derives DD, DDD or epsilon. DDD or epsilon. DDD or epsilon. Tell me whether this grammar is ambiguous. Try this. Tell me whether this grammar is ambiguous. Very good, Prince and Prashant. This grammar is unambiguous, right? So what will A derive? A derives A star. What will B derive? B derives BB star. What will C derive? Capital C derives C plus. What will capital D derive? Capital D derives DD star. Capital D derives DD star, right? Now S derives AB, S derives CD. Now what is language of AB? Language of AB is A concatenated with B. A star, BB star, right? What is language of CD? Language generated by CD. Language generated by CD is C plus DD star. C plus DD star, right? Now what is the intersection? L of AB intersection L of CD. So you can clearly see that epsilon is not there in the intersection. CD does not derive epsilon, right? And here there are A's and B's, here there are C's and D's. There is no intersection. Intersection equal to 5. Therefore, all these strings are going to be produced separately, right? So this grammar is unambiguous, okay? Now, rule number 2. left recursion and non-determinism can lead to ambiguity. Left recursion and non-determinism may lead to ambiguity. Right? But not always. Right? Tell me about this grammar. S derives S plus S or A. S derives S plus S or A. It has left recursion as well as right recursion, right? Tell me whether this grammar is ambiguous or not. S derives S plus A or A. Tell me whether this language is ambiguous or not. Tell me whether this language is ambiguous or not. Tell me whether this grammar is ambiguous or not. Tell me whether this grammar is ambiguous or not. Unambiguous, huh? Prince, try this. Is it unambiguous? Prince, is it unambiguous? It is ambiguous, right? S derives S plus S, S plus S, A, A, A. This is A plus A plus A. Similarly, S derives S plus S, S plus S. This is A, this is A, this is A. Right? Right? So we got two parse trees for the same string. Therefore, this language is ambiguous. Therefore, this language is ambiguous because it is both left recursive and right recursive. So the tree is growing to the left side once and tree is growing to the right side once. Right? That is why this is ambiguous. Now tell me about this. S derives S plus S, S star S, A or B or C. S derives S plus S, S star S, A or B or C. A or B or C. Tell me whether this grammar is ambiguous. Tell me whether this grammar is ambiguous. Tell me whether this grammar is ambiguous. Hello? Hello? వినపడుతుంది. ఫస్ట్ కదా పడతాయి పడతాయి పడతాయి. Very good. This is ambiguous because either, even if you take this is ambiguous, and adding this, it is also ambiguous, right? So in compiler design, we will see how to do the unambiguous grammar for this. So if I have s plus s, s star s, this is going to derive a, b, let us say c. And if I have s derives s star s, s derives s plus s, a, b, c, here a plus b into c, here also a plus b into c. Here star is getting executed first, here plus is getting executed first, right? So precedence is not taken care in this. So in compiler design, we will see how to use disambiguating rules in order to find out the unambiguous grammar for this language. Okay. So left recursion and left factoring may lead to ambiguity, but not always, right? For example, tell me whether this language is ambiguous or not. There is left recursion here. S derives SA or epsilon. There is left recursion. Tell me if this grammar is ambiguous. Tell me if this grammar is ambiguous. There is left recursion here. Tell me if this grammar is ambiguous. There is left recursion. So my question is, will left recursion always cause ambiguity? Is this grammar ambiguous? There is left recursion. Is this grammar ambiguous? Very good, Prashant. This grammar is unambiguous, right? So there is only one way you can generate epsilon. There is only one way you can generate a single A. There is only one way you can generate two A's. So take any string, there will be only one parse tree possible. Take any string, there will be only one parse tree possible, right? Now let us say left factoring, or let us say non-determinism. Non-determinism, right? So what is non-determinism? If the right hand side productions, if a variable has two or more productions, and if they have common prefixes, then they are called non-deterministic grammars. For example, if I have grammar like this, S derives alpha x or alpha y. If you see this, there is common prefix. This is called non-deterministic. There is common prefix, right? Or if you see some grammar like this, S derives ABC or ABD. If you see some grammar like this, there is common prefix. there is common prefix, right? Or if you see a grammar like this, S derives AA, AAX, or S derives BA, AA, AAY. Now there is common prefix, right? Sometimes they may lead to ambiguity. For example, non-determinism may sometimes lead to ambiguity, not always. Remember that, not always. Okay, these are just guide rules. These are just guiding rules. Okay, you cannot say that if a grammar is non-deterministic, it is ambiguous. You cannot say that, right? Now answer this question. S derives AA or AB. A derives small a, B derives small a. S derives AA or AB. A derives small a, B derives small a. A derives small a, B derives small a. Is this grammar ambiguous? Is this grammar ambiguous? This grammar is ambiguous, right? Why? Because A is common anyway, and capital A is generating small a, capital B is generating small a. There is intersection part, right? So S derives AA and A derives A. S derives AB and B derives A, which means for AA we got two parse trees, therefore this is ambiguous, right? Now answer this question. S derives AAA or AAB, AAA or AAB. A derives AA or epsilon, B derives A. A derives AA or epsilon, B derives A. Tell me if this is ambiguous. Tell me if this is ambiguous. This is ambiguous, right? So anyway, AA is common. Now let us see what is A deriving. A is deriving A star. And what is B deriving? B is deriving A, right? Now you take L of A intersection L of B. L of A intersection L of B, right? Now this is going to be A star intersection A is A, which means there is a common symbol which is derived by A and B. There is a common string. So anyways, initial part is same and there is a common string. Therefore, there are two ways to generate that particular string. So S derives A derives A derives and epsilon, or S derives B and B derives A, which means for A, we have two parse trees. Therefore, the grammar is ambiguous. Therefore, the grammar is ambiguous. Right? Right? Now tell me about this. S derives A or AB. A derives A or epsilon. B derives BB or epsilon. B derives BB or epsilon. Tell me whether this grammar is ambiguous. Tell me whether this grammar is ambiguous. Tell me whether this grammar is ambiguous. Prince, check it one more time. Check it one more time, Prince. Check this. This grammar is ambiguous, right? Anyway, A is common in both of them, and let us see if A and B generates any common string. Let us see if A and B generates any common string. What does A generate? A generates A star. What does B generate? B generates B star, right? Now what is language of A intersection language of B? It is A star intersection B star, which is epsilon, which means A is common and capital A and capital B are generating a common string epsilon. Therefore, you may get two parse trees, right? So S derives A derives epsilon, S derives AB, B derives epsilon. So non-determinism may also lead to ambiguity, not always. Not always. Okay? Okay? Not always. For example, tell me about this. S derives AA or AB, A derives A, B derives B. This is a non-deterministic grammar. Is this ambiguous? This is a non-deterministic grammar. Is this ambiguous? This is a non-deterministic grammar. Is this grammar ambiguous? Very good. This is unambiguous. Even though it has common prefixes, which is non-deterministic grammar, it is unambiguous. So we cannot really say that every non-deterministic grammar is ambiguous, right? So every left recursive grammar need not be ambiguous. Every non-deterministic grammar need not be ambiguous, but there are chances that they may be ambiguous. So you have to carefully check it. Okay. So this is not an algorithm. These are just guiding rules. There is no algorithm to decide whether a grammar is ambiguous. So ambiguity problem is undecidable, which means there is no algorithm. Okay. So if you see this grammar, S derives AA, the language has only two strings. S derives AB, right? AA and AB, and we got single parse tree for AB and AA. Therefore, this is unambiguous, right? Now the rule number 3 is presence of SS. Now the rule number 3 is presence of SS. So whenever SS is present, you have to be careful. In most of the cases, it will lead to ambiguous grammar, right? For example, if I write like this, S derives AB or BA or SS or epsilon. Can you tell me, let's forget about ambiguity and unambiguity. What is the language generated by this? Forget about ambiguity or unambiguity. What is the language generated by this? Forget about ambiguity and unambiguity. What is the language generated by that grammar? What is the language generated by that grammar? Forget about ambiguity, okay? We will see ambiguity. What is the language generated? Equal number of A's and B's. So whenever you have a grammar like this, whenever there is SS and epsilon, what you can do is you can write it as AB plus BA star, right? Whatever is here, you can take them and put a star whenever SS derives epsilon is there. Okay. Now tell me whether this grammar is ambiguous. Now tell me whether this grammar is ambiguous. So this grammar is clearly ambiguous, right? Why? If I want to generate epsilon, I can directly generate it. Or if I want to generate epsilon, I can generate like this also, right? So for epsilon, we have got two parse trees, therefore the grammar is ambiguous. Now let us say S derives A or C or SS or epsilon. S derives A or C or SS or epsilon, right? What is the language generated? Just now I told you, right? Whenever there is SS or epsilon, you can take the remaining part and you can put a star. So the language generated is A plus C star, right? Is this ambiguous? Yes. Just like previous example, this is ambiguous. If you want to generate epsilon, you can generate epsilon, or you can generate epsilon like this. You can generate epsilon like this. There are two ways to generate epsilon, right? Therefore, the grammar is ambiguous. Therefore, the grammar is ambiguous. Now answer this question. S derives AB or BA or SS or A. S derives AB, BA, SS or A. Is this ambiguous? Is this grammar ambiguous? Very good. So this grammar is ambiguous. How are you going to say that this grammar is ambiguous? So S can derive SS and this S can derive SS. This S can derive A. This is one way. Otherwise, S can derive SS. This S can derive SS. A, right? So for the same string, we got two parse trees. For A, we got two parse trees. Therefore, the grammar is ambiguous. Therefore, the grammar is ambiguous, right? Now answer this question. S derives AS or A or epsilon. S derives AS or A or epsilon. S derives AS or A or epsilon. Very good. This grammar is ambiguous, right? This grammar is ambiguous. So how is this grammar ambiguous? How is this grammar ambiguous? S derives AS. Here S may derive A, this may derive epsilon. A. Now S derives AS. This may derive A, this may derive epsilon. Right? So we got A here, A here. We got A here, A here. So for A, we got two parse trees. So the grammar is ambiguous. Right? Answer this question. S derives AS or B or epsilon. S derives AS or B or epsilon. S derives AS or B or epsilon. Kiran, you can take GATE 2027, right? Parakram GATE 2027 you can take. S derives AS or B or epsilon. Very good. So S derives AS and this S derives AS epsilon. So this is generating 4 A's. Similarly, S derives AS and S derives AS and this one will derive epsilon. So this is also deriving 4 A's. There are two parse trees, therefore the grammar is ambiguous. So this is about ambiguous grammars. Okay. Tomorrow we will see ambiguity of languages. Okay. Thank you. Good night. Good morning. Jai Hind.